So we're going to start with a review of the skills that we're going to be using throughout the course. And the main thing that we need to be able to be comfortable with is factoring. So from grade 10, there are 4 basic types of factoring. The first is common factoring, where we're looking for something that's in common between the different terms in the expression. So we're going to look at these terms and we're going to say, oh, these are both multiples of 3. They both have an A and they both have a B. And then I'm going to think, oh, divide the 6 by the 3, that gives me a 2. I've moved the A out, and B squared divided by B is still B. The sign stays the same because I haven't factored out a sign. 15 divided by 3 is 5. A squared divided by A is A. And B to the power of 1 divided by B is B to the power of 0, which is 1. So I'm not even going to write that. And now I have common factored it. The second type of factoring that we did was simple trinomials, and this was where we set up 2 sets of brackets and we put this x term in front, and then the second step was to look at the second sign here and think about whether or not it was positive or negative. We know that in order to get a negative through multiplication, we need 1 plus 1 minus. We can fill in our signs there. And now we're looking for factors that multiply to 6 but add to 5. And so we've got 2 and 3 and 1 and 5. And in this case, we're going to have to go with, 1 and 6. And we're going to go with 6 and 1 because 6 take away 1, or negative 6 plus 1 rather, is negative 5. So these multiply to negative 6 and combine to negative 5. After that, we looked at difficult trinomials, and difficult trinomials had an extra step in them. So before we could really get started, we needed to get rid of these. We need to take our A term and our C term, so this is A, this is C, and multiply them together. So 6 times 15, 6 times 15 is 90. So now we're looking for 2 factors that multiply to 90 and combine to negative 1, my B term here. And so that must be 10 and 9. And because I want it to be a negative 1, I'm going to have a negative 10 and a positive 9. So this we kind of do off to the side. Then we're going to rewrite this expression. And we're going to put our factors in the spot of that 1x. Okay, so we've taken this 1x and we've put these 2 factors in that spot instead. And we haven't changed anything because 9x minus 10x is negative 1x. After that, we're going to factor by grouping. So we're going to make 2 groups, and we're going to think about what the common factors are again. So common factor in the first group is 3x, which leaves us with 2x plus 3. Common factor in the second group is 5, which also leaves us with, negative 5, which also leaves us with 2x plus 3, and I factored out that negative. After that, we see we have another common factor of 2x plus 3, and this is how we know we've done it correctly. So we can move that common factor out front. We can factor out 2x plus 3 from each of these terms, which leaves us with 2x plus 3 multiplied by 3x minus 5. A difference of squares was the fourth type of factoring. So in that, we took the square root of both terms and had opposite signs inside the brackets. Okay, moving on to grade 11. In grade 11, we looked at factoring through grouping. So in this first case, we would take these 2 as a group and then these 2 as a group. And the first 2 have x squared in common, so we'll factor out an x squared. That leaves behind an x minus 2. And the second group has a 5 in common. That leaves x minus 2. And we notice that we have this new common factor here, so we're going to move that out to the front. So we're going to have x minus 2 out front, and then we have what's left behind, x squared plus 5. Then we also had just these general rules of the sum of cubes, where we could factor out a sum of cubes following this general format. So if it was a sum of cubes, we would have the cube roots with a plus, the squares, a subtract sign, and the other square. And then the difference of cubes was really the same, except it had these opposite signs here and here. Okay. Then we also talked about the factor theorem, which just stated that a polynomial has x minus b as a factor if and only if the function at b is equal to 0. So that means that it has a root at b. And after that, you use long division to continue to factor that expression. Okay, so new for us now are these two ideas, factoring expressions with fractional or negative exponents. So in this first one, we have the x in common, just like before. So we all have x's in common, and we want to factor out the lowest exponential value. So in this case, the lowest exponential value is -3. So I'm going to factor out x to the -3. And now I'm going to think, if I take away -3 from -1, so -1 take away -3, that will give me x squared. -2 take away -3 will give me x to the 1. And -3 take away -3 gives me 0. Okay. Now I don't need to write this term here because that's just the value of 1, and I don't need the 1 on there either. So clean that up like that. Okay, in this case, I'm going to look at my different fractional exponents here. I'm going to look for the smallest one, which is 1/2, and I'm going to factor that out. So x to the 1/2 comes out. Inside the brackets, 2x. 5/2 take away 1/2 is 4/2. 4/2. I'll write that there. And I'm going to start my next line right now anyways, because 4/2 is really 2. 3/2 take away 1/2 is 2/2. So that's actually just 1. And 1/2 take away 1/2 is 0. Okay. Now, if we wanted to, we should double check and make sure that these can't be factored further using one of the other techniques from grade 10, and otherwise we're done. So we're going to do all of the examples on page 3, questions 1 through 4.